Hi, my name is Jason Michael with metric number D20201095521. Today I'm gonna talking about differentiation of logarithmic function and also differentiation of exponential functions. So the first one, we see at the theorem first for the first subtopic. For x more than 0, the derivative of the logarithmic function of y equals to log ax is given by d over dx log ax equals to 1 over x log ae. So to prove this equation here, we will see here. From the definition of the derivative, we have d over dx log ax equals to limit as h approaches 0 log a x plus h minus log ax over h. So we solve this equation to get this answer. How do I get this? It is log a minus log b is equals to log a over b. So that's why here we get x plus h over x. Then we cancel off x to get 1 here, h over x. And then how do we get 1 over h? Eventually we have 1 here. So 1 over h, and then we separate the fraction to get this answer. Now we will introduce a new variable, which is z equals to hx, and h equals to zx. So since h approaches 0, it implies that z also approaches 0. So we will substitute from this formula. We will substitute h with zx here, and we'll substitute h over x with z. We solve this, and then we get the final answer here, this. So we note that this is equals to e. This equation here is equals to e. So when we rewrite the equation, we'll get d over dx log ax equals to 1 over x log ae, the same as the theorem. So it has been proven. Now let's see some exercise and solution. So this is the first question. Differentiate the following expressions with respect to x. So if we see an expression like this, the first step we must do is to change it to natural log. After we change it to natural log, then we apply some rules to get this equation here. After we get this equation, we can differentiate it. So this is how we differentiate it. When we differentiate natural log of 6 plus natural log of x, the natural log of 6 becomes 0. This because it is a constant, while when we differentiate natural log of x, it becomes 1 over x. This is a note here. The derivative of natural log of x is equals to 1 over x. And then we rearrange it, we get the final answer is equals to 1 over x natural log of a. So we move on to the second question, also the same, differentiate with respect to x. So we get an expression here, which is y equals to natural log x squared. If we see like this, we can bring the power to the front, and then we get 2 natural log of x. If we get this equation already, then we can differentiate it like this. Differentiate 2 natural log of x with respect to x. Then we can bring the number 2, this number 2, into the front. Then it becomes like this. After that, we differentiate again this natural log of x. As we stated earlier, natural log of x, when we differentiate it, it becomes 1 over x. So 2 times 1 over x is equals to 2 over x. That's all. So the third question is differentiate gt equals to 4 log 3t minus natural log of t. When we differentiate gt, it becomes g prime t. Then we change the log into natural log, like the natural log of t. So this is the general formula to change from log into natural log. So when we differentiate log au with respect to x, it becomes u prime over u natural log of a. So we apply it here, and then we get 4 over t natural log of t minus, when we differentiate natural log of t, it becomes 1 over t. As I mentioned earlier, differentiate natural log of x, it becomes 1 over x. So we rearrange it a little bit, and then we get the final answer. G prime t equals to 4 over t ln 3 minus 1 over t. That's all.
The second one is differentiation of exponential function. This is the theorem. The derivative of y equals to a power x is given by, when we differentiate a power x with respect to x, we'll get the answer equals to a power x natural log of a. We'll see some exercise later to prove this. And if we have a case when a equals to e, then we'll have the following. So in this case here, when we differentiate e power x, we will eventually get the same thing of what we differentiate. So we'll see some example later.
So this is the exercise. It needs us to differentiate the following with respect to x, which is y equals to 10 power x. So as stated in the theorem earlier, when y equals to a power x, then if we differentiate it, it becomes a power x natural log of a. So we apply it to here, then we will get 10 power x natural log of 10. Then the second one, as stated in the theorem earlier, when a equals to e, then if we differentiate e power x, we will get the same as what we differentiate earlier. So we apply it here, 3 e power x. So when we differentiate it, it becomes itself. Why? Because our a here is equals to e. So in this equation, our a is equals to 3e. So 3e power x. Then we get the answer here. That's all.
So thanks for all of you. I hope you all can understand my video and my explanations. Thank you.